I made this app for Swift Student Challenge. Understanding automata theory can be challenging for many students, especially when dealing with concepts like deterministic finite automata, non-deterministic finite automata, and pushdown automata. These topics form the foundation of theoretical computer science and play a crucial role in areas like compiler design, artificial intelligence, and formal language processing. However, for many learners, the abstract nature of this concept makes them difficult to grasp. In DFA section, you can design DFA automata, perform test and validation on input string, and explore the transition table equivalent to the DFA design. From template button, I can choose a template. For let's start with a basic example. Binary number divisible by 3. When I click on that, it's create a DFA automata designed for binary number which is divisible by 3. Let's give an input string and test the input string validation corresponding to this DFA. 1 1 1 1. 4 times 1 is divisible by 3, so perform the testing. When we perform the testing, you get the little animation, a dot animation from one state to another state signifying from on which alphabet you get one state to another state. If I click on the forward button, you get another animation like processing symbol 1 step 2 by 4. And when the input symbol reach last state, it shows if the string is accepted or rejected. In this case, the string is accepted. If I add another one in the input string and perform the test again, okay, this time string is rejected because 5 times 1 is in binary is not divisible by 3. This is the basic example I have given. You can design a complex DFA design and perform the testing for it. For example, your DFA design isn't in the template. You can create your own. Let me expand the canvas here. Let's add a state A. A is my initial state. Let's add another state. B is my accepting state. Okay. These two states are created, and let's give a transition between them. Over the alphabet 1, perform the transition from state A to state B. You get the little nice transition line here, and one or more on 1 from state B to state B. It's give you a nice little loop. This DFA for at least one in the input string, like 1 the testing would be success, string accepted. If there's no 1, only string start with 0, but the 0 isn't in our DFA design, so the testing no transition found for 0 from state A. Okay. And many people struggle during making the transition table for the DFA. Like if you are struggling designing DFA transition table, you can, whatever DFA you have designed, you can simply click on this transition table button and get the corresponding transition table. This transition table automatically generated. You don't have to do anything. It's automatically generated whatever DFA you have created. Like if I reset this, choose DFA from template, see the transition table automatically created corresponding to the DFA, and I save this DFA. The same for NFA with the NFA logics. Like I take any example from here. I can take palindrome. I can take, let's see, string starting with A and B. In this NFA, all the string starts with A and B get accepted. B. This input string, the string starts with A and B. Okay, this get accepted. The fun part about the NFA is when we convert NFA to DFA, first we have to create the transition table for NFA, then we have to create the equivalent transition for table for DFA corresponding to that NFA transition table, then we design DFA. It's a long process, but if you're struggling with designing NFA transition table and converting to the DFA transition table, you simply click on this transition table button. You get the automatically you get the NFA transition table and its equivalent DFA transition table. You don't have to do anything. It's automatically generated whatever design you have created in the canvas. Yes, same for the pushdown automata, but in the pushdown automata you get the little stack visualization here. In the Chomsky classification section, it's the informatory section about Chomsky hierarchy. You get four type of grammar: type 0, type 1, type 2, type 3, unrestricted, context free, context sensitive, context free, and regular. These circles are not just for show. When you click on them, it's give you the overview example property about the unrestricted type 0 grammar. And when you scroll down, you get to know more about the type 0 unrestricted grammar, like equivalent machine corresponding to type 0, like Turing machine, and type 0 unrestricted grammar, more general form of grammar, no restriction or production rule. You get some examples, and Turing machine simulation. You can explore the other grammar from the segmented control, sorry. This is type 1 context sensitive. The corresponding machine is linear bounded automaton, type 1, type 2, and type 3. And whatever DFA, NFA, PDA you have saved, you can export from this export button. You can export in a PDF format also. My motivation behind building this is very simple. I want to make automata accessible and intuitive for engineering student. As an engineering student myself, I experienced the challenging of learning DFA and NFA through textbook and lecture without truly seeing how these automatas actually function in practical. I realized the interactive approach could make a significant difference in comparison. AutomateX are designed to fill the gap by allowing students to experiment, iterate, and learn dynamically, rather than just passively memorizing concepts and all. Thank you.